Hello everybody, hope we're all keeping well, all working hard. So this next stage in the course is linked to the stuff we've been doing about series and parallel circuits, but it's called a voltage divider circuit or a potential divider circuit. And we're going to do another one of those, I like to call it a virtual experiment, it isn't really, but I'm going to use the simulation software that we used before to try and, get a grip on this topic. So linked to what we've been doing before, so this is a series circuit, and it's also known as a voltage divider circuit because if you know the voltage of the battery or the power supply, it's going to split up across each of the components in the circuit. In this case it's two lamps, but the lamps are just resistors really, and so therefore the voltage splits up across each one in such a way that the supply voltage would be V1 plus V2. So if the voltage across that bulb was V1, voltage across that bulb would be V2, and obviously that's the supply voltage. And so if that's 1.5 volts as the supply voltage, then the voltage across each bulb might be 0.75 volt, 0.75 volt, because the voltage, or sorry, the lamps in this example are identical. So they've got the exact same resistance. So the voltage splits equally, but it doesn't have to be that way. You know, if you've got two different values of resistor, then the voltage will split up in a different way. For example, it could be 1 volt and 0.5 volt. All you know is that that volt and that voltage must add up to supply voltage. That's the equation from series circuits that we've done before. So what we're going to do today, hopefully, is you're going to use that FET, the Colorado simulation stuff. That's a link, hopefully, there to do, as I say, a virtual experiment and investigate what happens with the ratio of resistors when we do different values of resistors, how that affects V1 and V2, as we're going to look at in a wee second now. First of all, you better do control click on that link, which will open up the Colorado software. And then if you put a battery in the circuit and then two resistors. Now automatically the default position is that the battery is 9 volts and each resistor is 10 ohms. So we're putting two resistors the same and then the voltmeter can be connected. So hopefully as a quick screenshot of what you should see. So you've got a 9 volt battery and you've got two 10 ohm resistors. I put the voltmeter here, I haven't actually connected it and I don't want to give the game away. But that's the sort of circuit, so it's a nice and easy circuit. Incidentally, I'll say this in the notes in a wee second or two, that we're going to put different values of resistors, and how you do that is you just click on the resistor and then there's a slider you can use to alter the values of the resistor. So that's the circuit that you should be setting up, and then we're going to look at the voltage across that resistor and the voltage across that resistor, and we're going to build up a relationship for that. So I want you to copy this table into your Jota, and then you're going to use the software to fill in the missing values, right? So I've given you values for R1 and values for R2, okay? So the first one would be the default 10 ohms and 10 ohms. So you measure the voltage across that resistor, and then you measure the voltage across that resistor, the 10 ohm, and see what they work out as. And there's two columns at the end here. The first one is R1 over R2. What that means is that resistor, the value of that resistor divided by that resistor, and obviously 10 over 10 gives you 1, 15 over 10 is 1.5, and so on and so forth. And you're going to do the same for V1 over V2. Once you've measured them, you put them into the table. So just pause the video if you're doing it that way to copy the table down, and then you're going to use these values in the software to calculate or investigate what you get for V1, V2, etc., etc. So from your results, there should be a simple relationship you find, that the ratio of the resistances, it's difficult to say, equals the ratio of the voltages. In other words, this relationship here, which you'll find in your formula sheet, your relationship sheet again. So R1 over R2 equals V1 over V2. So in other words, the voltage splits up in the ratio of the resistors. Now, this is an important part for the next major topic we're going to go on to, which is electronics, where we've got voltage divider circuits that are using sensors like LDRs and thermistors, etc., because the resistance of these sensors changes and therefore it changes the voltage. So this whole thing here about how the resistors make the voltage split up is an important bit to remember. And the main thing to get is if you've got in a voltage divider circuit, you've got a greater value of resistor, then it gets a greater share of the supply voltage. That's the main thing you really need to take from this. The main bit for the electronics part is when you've got two resistors in a voltage divider circuit, the bigger value of resistor gets the bigger share of the voltage, because we'll come back to that. So lastly, we're going to do this example using this equation. So you've got 12 volt power supply, and we've got two resistors. Doesn't really matter which one you call R1 and which one you call R2, but say R1 is the bottom one, R2 is the top one. We know that V1 is 8 volts and we've got a 12 volt supply. So the question is, what's V2 first of all? And then lastly, the more complicated bit is working out R2. So V2, you should hopefully recognize that V1 plus V2 adds up to give you 12. So basically, V2 must be 4 volts. So that's quite straightforward, hopefully. You should get that one. Now the R2 one, we're going to have to use this equation here. So we've got R1 over R2 equals V1 over V2. So then that's the equation, then you substitute in your numbers. So we've got 6 over R2 equals 8 over 4. Now, at this stage, if you're kind of okay at your maths and you can recognize a pattern, 8 over 4 is 2, so 6 divided by something gives you 2. So, you know, you probably figure out that R2 is going to be 3 ohms. But let's go through the procedure, because really what we're going to be doing here is like your bit like the gas law stuff. We're going to be doing cross multiplication. So cross multiplication means that that times that equals that times that. Doesn't matter which way around you do it, but the top tip that I would give you at this stage is that you do the one with the unknown on the left hand side of the equation. So your next line should be that 8 times R2 equals 6 times 4, nearly there. So therefore you want to have R2 on its own, so the 8 gets divided underneath that. I've done the 6 times 4 in my head, 24, divided by 8, which does actually give you the 3 ohms. Okay, but please do try the computer software. You know, it maybe gives you a better grasp of the whole thing, and it, you know, breaks up the monotony of perhaps of just doing loads and loads of questions. So do give it a go, and there'll be another video about the next part of the voltage divider circuit coming up soon. But okay guys, I'll catch you later.